Welcome to The Explainer. You ever wonder how your phone just knows the right password? Or how a video game character decides when to jump? Well, today we're going to pull back the curtain on the simple rules that let software make all those smart decisions.
It's definitely not magic, but it is incredibly clever. It all boils down to this one big idea that programmers call flow of control, which is really just a fancy way of saying the path that the instructions follow.
All right, so where does a program's journey even start? Well, it begins on what you could call the straight road, the most basic default path a computer can take.
So, this really simple one-by-one way of doing things is known as sequence. It's just like a bus following its route, you know? The code runs the first line, then the second, then the third. No detours, no choices. Just a straight shot from beginning to end.
And this whole idea actually has a name, flow of control. It's literally just the order the program follows its instructions. And that default flow, that bus journey we were just talking about, that's called sequence. One instruction right after the other. Simple as that.
And see, that's where we hit a wall with the straight road. It gives us zero choices. If we want our programs to be actually useful, they've got to be able to handle different situations in a smart way.
So how do we fix this? How do we give our programs choices? Well, we teach them how to handle a fork in the road. And this is our first major tool for building some really smart logic.
It's a lot like you in that shop. A program has to look at its options based on certain conditions. Is this the right color? Or is this even in stock? In the world of programming, this whole act of making a decision is called selection.
So what this really means is that selection lets our code, it lets it ask a question, like, hey, is this number bigger than that one? And then based on the answer, it acts. It creates two or even more possible paths for the program to go down.
Okay, here's a perfect classic example. Checking if someone can vote. The program asks one simple single question. Is the age 18 or more? If the answer is true, it zips down one path, but if it's false, the flow of control gets sent down a totally different road.
And just like that, bam, we've solved our original problem. By adding a simple if-else decision, we can tell the program to always subtract the smaller number from the bigger one. The program can now change its behavior, which makes it way smarter and way more useful.
Okay, making decisions is super powerful, right? But what about stuff we need to do over and over and over again? Well, that's where our next tool comes into play. I mean, can you even imagine trying to write that out? One line for every single number, all the way to 100,000? No way. It would be impossible. This is the perfect kind of problem for a new tool. One that's built for huge repetition and, honestly, just being efficient. Just look at the difference here. This is the power of repetition, or what programmers call looping. Instead of writing 5 separate instructions, we just write one main instruction and tell the computer to repeat it. It is the ultimate tool for efficiency. It's a real game changer. A good way to think about it is kind of like the life cycle of a butterfly. It's a process that repeats itself in a controlled cycle. The code inside that loop will just run again and again for as long as the loop's condition stays true. And get this, programmers even have tools to change the flow from inside the loop itself. A break statement? That's like pulling the emergency brake. It stops the loop completely right then and there. A continue statement is a little different. It's more like skipping a song on a playlist. It just says, hey, forget this one, and jumps right to the next item in the cycle. All right, so now we've got these 3 main tools in our toolkit: sequence, selection, and repetition. Now we've got to learn the rules of the road that hold them all together so we can start building even more complex stuff. This quote from Python's creator, Guido van Rossum, it actually reveals a huge rule of the road, at least in Python. That little bit of space at the beginning of a line, it's not just there to look pretty, it's the actual structure. Indentation is how you tell the computer which lines of code belong to which if statement or which for loop.
And this, my friends, is where things get really interesting. When we start combining our tools, like putting a loop inside of another loop, well, we can create some surprisingly complex behaviors from just a few simple rules.
So, how does this actually work? Let's break it down. Notice that for each single time the outer loop runs, the inner loop completes its entire cycle. So, the first time around, the inner loop runs just once. The second time, it runs twice. This simple nested structure is exactly how programmers can generate these incredible, complex patterns with just a handful of code.
So, there you have it. That's the whole toolkit. These 3 fundamental structures, sequence, selection, and repetition, they are the essential building blocks of pretty much every piece of software you use, from the calculator on your phone to the most complicated video games out there.
Seriously, think about it. When your phone asks for your password, that's selection. When your music app plays through a whole playlist, that's repetition. Once you start looking for it, you'll see this flow of control absolutely everywhere.